Welcome back to our next lesson, graphing linear equations. Our objectives are to define what a solution is for an equation, understand the relationship between equations and their graphs, understand which equations produce linear graphs or line graphs, sketching graphs for linear equations, and finding a graph's intercepts. We'll get started with equations and their solutions. The type of equation we're typically going to deal with are two variable equations. For instance, if I wrote y equals x plus 1, this would be a linear equation in two variables. So what makes this linear? Mainly the variables that you have are not multiplying to any other variables, and the only operation that'll exist between these two variables is perhaps addition or subtraction. So what I mean by that is, if you were to rewrite this equation as y minus x equals 1, you could see that the only operation existing between y and x when I write the same equation in this format is subtraction. So y and x are not multiplying. They're only going to either add or subtract with one another in this equation. Okay, and that's really why this is linear. That and the fact that we don't have anything like y squared or x cubed or x or y to any other power. Whenever there's nothing present in the exponent area of a variable, realize it's just an invisible 1, right? So y is really y to the 1 power, x is really x to the 1 power. Let's just summarize what makes this a linear equation. Now you're also going to notice that when we start graphing these equations, they're also going to have a linear pattern. Let's talk about solutions to equations. So when we have an equation, let's say 2 equals 4. An equation has value. Write that down. Equations have a value. They are either true or false. So that's the value. Okay, a true value and a false value. So when we see an equation that says 2 equals 4, the value of this equation, we would say in this case, is false. An equation with a different value would be something like 9 equals 9. This is true. We say the value of this equation is truth or true. But this is not what a solution is. A solution is a set of values to assign to variables that makes an equation true. If we come up with an equation, okay, so an equation such as x plus 2 equals 5. What set of numbers can we assign to this variable that would make this equation true? We would say, well, we know that 3 plus 2 is 5. Therefore, it must be the case that x has to be 3 for this equation to be true. So then we say that x equals 3 is the solution to this equation. Okay. So this equation here has solution x equals 3 because 3 plus 2 is 5, and that's what makes this true. Now can there be more than one solution to an equation? Absolutely. For instance, x squared equals 1. What's a possible solution to this? Well, you can say x can equal 1 because, okay, so because 1 to the second power is 1. Okay. But we also know that negative 1 to the second power is also 1. So that means x can also equal negative 1. I've presented to you a set of values that make this equation true. Some would call this a solution set. Okay, so now equations in two variables. Let's say we had x plus y equals 1. If we let x be 1/2 and let y be 1/2, and we insert these values into this equation, we see then we get a true statement. 1/2 plus 1/2 is 1. So this means that together at the same time, if I let x take the value 1/2 and y take the value 1/2, then the equation is satisfied, or the equation is true. So a solution would be together x and y equaling 1/2. But instead, we use what is called an ordered pair to express the solution. When there's two variables, we're going to use an ordered pair like this, similar to the graphing ordered pair. And so we would say that our solution is 1/2 comma 1/2. Now, is that the only solution? Can you think of another pair of numbers that you could put into x and y so that this equals 1? Sure. Let's say x were 2. What would you need to let y be so that this equation equaled 1? Well, if I let y be negative 1, then 2 plus negative 1 will equal 1. So there's another solution. There's another ordered pair. Okay, so overall, our solutions to equations in two variables are ordered pairs, where the number on the left is the x value needed and the number on the right is the y value needed to make the equation true. So now let's see how solutions relate to the two-dimensional plane and also the graphs that emerge from these solutions. Y equals x plus 1. So what are possible solutions? Let's say we let x be 1. What value of y would we get? We would get 2. Why is that? Well, think about it. If you put a 1 into x here, then 1 plus 1 is the outcome of y. And 1 plus 1 will be 2. So our y value over here is going to say 2 when x is 1. Now let's plot that. Okay, so we're going to do what is called plot the coordinate onto the plane. Okay, so 1 comma 2, I get 1 for x, 2 for y. So now let's come up with another point. Let's say I chose x to have the value negative 2. Now why negative 2? Why am I able to choose my x value? The way this equation's set up, it's set up so that y is what is being solved for. So when you insert a number into x, you instantly get the y value as a result. So that's why I'm choosing x values and getting y values. And that's going to be a big theme in this course, is how x can be chosen and y is determined by that choice. So if I let x be negative 2 and add it to 1, because that's what the equation says, then we see that y should be negative 1. And so that's going to be the coordinate for the y value. And then I'm going to plot this onto the plane. Okay, so there's my x value and my y value. So we go over to -2 and down to -1. And I go ahead and mark my point. So now we have 2 points. Okay. So what I want us to do with these 2 points is I want us to connect them very carefully with a line. I'm going to start here at this point and connect it but then I'm also going to extend this. Okay. So it's a line that goes through the 2 points. That's really what I want. And I'm going to show you why in just a moment. So I extend this line through the 2 points that I made. So here are my 2 points from earlier, right? And I created a line that goes through them. Now what I want us to do is look at every other point and pick one that belonged on this line, but not the ones that we created or found. Instead, let's say I go to this point right here. Okay. And what point would that be? It would say x is 2, y is 3. So do these pair of numbers, if I substitute them into the variables x and y, do they make the original equation true? Okay, so here's our original equation, y equals x plus 1. So if I take x equals 2 and insert it into x and add it to 1, I'm going to get y equals 3. So we see that this ordered pair is a solution to the original equation. And I just chose this point because it belonged on the line. Same thing goes for down here. What's this point over here? This is -4, -3. So if I were to take this x value, -4, and insert it into the original equation, y equals x plus 1. So if I put a -4 here and add it to 1, the result is the y value, and it gets to become -3. Okay, so there's my y. And that's what's the graph is showing the same information. So now you're starting to see that any point I pick on this line is literally a solution to the equation y equals x plus 1. And for this reason, we say that this is the graph of y equals x plus 1. So think of graphs as being a portrait of the solutions to an equation. Let's write that down. This is wonderful. Okay. So graphs are the portrait of solutions to an equation. That's the main takeaway here. So we're looking at a picture of every possible solution that this equation could have. And that's the relationship between solutions and equations. Now, let's continue on with the idea of graphing. So let's graph another equation. And let's just write an equation. We'll say y equals -2x plus 3. So the overall method you saw me use in the previous example is I did what is called graph by plotting points. The way the equation's written, notice y is isolated. When we see y by itself on one side of the equation, so realize equations have two sides. So if I put this imaginary barrier, think of this as like a wall. I have created two sides, a left side and a right side. So notice y is all by itself on the left-hand side of this equation. And everything else is on the right-hand side. So this is what I mean that y has been isolated. So this is a very special form of equation, and we'll get into that later on, what we call this. But for just simplicity's sake, we're just going to say that y is by itself on one side of the equal sign. Okay? So when you're in this situation, it's set up so that you choose your x value and you find your y value. So let's demonstrate what I mean by this. Okay, choose. Choose just means pick anything for x, any number. Now, keep in mind, we're going to end up graphing this. So you probably want to choose x values that are in front of you on the x-axis. So notice the number -25 is not an x value on this axis. So we don't necessarily want to choose that kind of x value. But I see there is a -6 on this x-axis, so let's just choose that. Okay, so now what I'm going to do is put -6 into this x. So this parenthesis I wrote, that is the x. In reality, variables are really just empty parentheses inside an equation. That's one of the best ways to think about a variable. It's just like an empty parenthesis ready to take on any value that you put into it. Okay, so in this case I put a -6. I chose -6. So now we're going to find the y. Finding means we're going to calculate the y value. So y in this case is whatever -2 times -6 plus 3 gives us. So we perform the multiply first based on the order of operations. -2 times -6 is +12 plus 3 means that y is 15. Okay. And there's our solution. When we chose -6 to be our x value, we ended up finding that y is 15. Okay. Now we're going to do this repeatedly. I want to do this like 2 or 3 more times. Choose an x value, then find a y value. And I want to organize all this information. So one way of organizing this information is to create what is called a table of values. Okay, so here's my x, here's my y. So we found that -6 was an x value that I chose, and the y value that resulted was 15. So there's my solution from earlier. Now I want to choose another x value, so I'm going to go ahead and erase this right here. Okay, let's make another choice. I'm going to choose x equals -2. So -2 times -2 plus 3 is going to be our y. So now we calculate -2 times -2 is +4 plus 3 makes 7. Okay, so when I chose -2 to be x, I got 7 as my y. Okay, let's do this again. Let's generate another point. So that's what we're doing. We're generating this table. We're just coming up with pairs of numbers that represent solutions to this equation. So now let's choose x equals 0. Well, the result for y will be 3. Okay, so when x is 0, y is 3. Now let's choose one more. Okay, so I'm going to erase again. Let's now choose positive 2. So negative 2 times positive 2 plus 3 is what y would be. And this gives me negative 4 plus 3 is negative 1. So our ordered pair would be 2, negative 1. Okay, so here are my table of values, and these are my solutions, okay, these ordered pairs. So what I'm going to do now is plot anything I can from this table onto the coordinate plane. So notice negative 6 comma 15 has no place on this coordinate plane because our y-axis only goes up to 7. Okay, so I can't really plot the first ordered pair, but I can plot the next point, negative 2 comma 7. And the next point, 0 comma 3. And the last point, 2 comma negative 1. So I want you to notice that when I started plotting these, a linear pattern emerged. These points line up, and that's supposed to happen. And so now I'm going to take my line and I'm going to extend it. Okay. A more accurate graph is one that has arrowheads at the endpoints. So if I use arrowheads like this, it tells the reader that this graph goes on forever in both directions. So notice, if I pick another place on this graph, like here, this is the point 3 comma negative 3. Is this a solution to the original equation from this ordered pair 3 comma negative 3? And notice it is true. Negative 6 plus 3 is negative 3. So part of this course, I'll also be teaching how to use a TI-83 graphing calculator. And we'll get started with how to graph a line or a linear equation. So notice all the y's are listed here. These are just different equations you could enter into the calculator at the same time. We'll just focus on y1 and we'll insert an equation into that. But before we get into that, let me talk about the plots at the top here. So if I use the up arrow key, I could highlight plot 1, and so you want to make sure that your calculator does not have plot 1 highlighted. If it is highlighted, just hover over it and press enter to unhighlight it. That's usually a common reason why a student will not be able to graph whatever it is they're trying to graph and they can't see it. It's usually because this plot 1 has been highlighted. So just try not to have that highlighted if you want to graph. Okay, so once that's unhighlighted, we could then focus on entering our equation. So we're going to enter negative 2x plus 3 equals y. So notice the calculator already has a y. So I'll start with negative 2x. Notice there's 2 buttons for what look like both minus or subtraction. There's this one on the right hand side of the calculator. So these are different buttons. This is your subtraction operation and this is your negative identifier. So if you're dealing with a negative number like -2 from this equation, then we would use this button at the bottom and we would not use the subtraction. So now we'll type -2x, and to find x you just go to this part of the calculator labeled xt theta n, and that's how you get the variable x. Then I'll hit +3. Now we'll press the graph button, and depending on your default setting on your calculator, or whatever setting you had on your calculator, you might have the same picture as me. And notice it's the same, very similar to the graph that I had just made by hand or without a calculator. We could adjust the window by going to the window button, and we could use this window button to modify the length of the axes. So sometimes we might need our axes to be larger or smaller than they currently are. So this is called a standard 10 by 10 window. And it gives me 10 tick marks along the axes. And X scale means each tick mark is 1 unit from each other. Okay, so X min, Y min, Y max, this just tells me how far down I want my axis to go on the Y axis. So here I have it set on -10 units, and the highest number on the Y axis is 10 units, and each tick mark on the Y axis is 1 unit apart. And don't worry too much about this X res equals 1. We don't need to modify that. The zoom button in the middle of the calculator here on the top row, this you can also access a standard 10 by 10 window quickly. Notice if I modify my window, say x-axis -1 to 3, and then my y-axis -5 to 5. Okay, so now I adjusted the axes. Now you get a slightly different picture. It's the same equation, just on a different scaled axis. But if I want my 10 by 10 window back, I could just go to the zoom menu and select 6, and instantly it gives me a 10 by 10 unit set of axes. I can also zoom in and zoom out. So there's a little blinking cursor, and you could use the directional pad to move it around. Select the spot you want to zoom at, say here, then press enter when you're ready to zoom in. And the calculator automatically adjusts with a closer view of that spot you selected. You can also zoom out if you like. Just press enter, and I could zoom out even further. Okay, so have fun with this, experiment with window settings. So another feature is the trace. If you press trace, a cursor shows up on the graph, and you can move this cursor through the graph, and it gives you different points. You see here at the bottom of the screen, I see the X and Y coordinate for this particular point. And it's pretty accurate to several decimal places. And then if I press left, I go further to the left of the graph, and then I could see the X, Y coordinate. Say I don't want to deal with all these decimals, and I wanted something without so many decimals, like let's say up to 1 decimal instead. I can access the calculator and tell it to just move around by 0.1 decimal at a time. So you would choose Z decimal on the zoom menu, And then notice when I press trace, the accuracy of the XY coordinates are now to 1 decimal place instead of several decimal places. So this is also helpful since these are typically numbers you deal with in a learning setting. And then I'll just go back to my standard 10 by 10. Now you can also tell the calculator which X value to be on the graph. In order to do this, you press trace and then just type any numbers, say 5, and then press enter. The calculator will then show me where on the graph is X equals 5. And now I see the point X equals 5, Y equals -7. So that's also another thing you can do. Here's X equals 1. And I could see that the Y value at this point is 1. So let's talk about tables of values. Earlier I made a table of values by hand, and I had to manually calculate these points. Okay, so it turns out this calculator also can generate the same table for you, and it'll save you lots of time. So to find the table feature, you're going to go to the graph button, but because table is written on top of the graph button in yellow, you're going to need to press the second button on the left of the calculator here. So second, and then graph, and then this table appears. So notice the X values are on the left, so I can move through the table of values using the directional pad. Notice the X values seem to be in consecutive order, and here are the associated Y values, and I can scroll to the Y column just by using the right button. And I can press the up arrow to get further lower on the X values to the negatives, and if I press the down arrow, it'll take me further or greater in size of X value. And notice they're all in order, so this is a default setting of the calculator. You can adjust this to any order you like. If you need the numbers to go by 2s, you can tell the calculator to do that for you. You could even erase all this and only insert custom numbers. Like, let's say I want to enter the numbers I have handwritten on the right here into the calculator. So to do that, I'm going to access the table set menu by going to second and pressing the window button. And then you'll see this screen, and hopefully you also see that both of the autos are highlighted, independent and dependent. So you're going to change independent to ask. So just move with the direction pad and press enter over ask, and leave dependent as auto. And then press second graph, and now notice your table is empty. Now your calculator is going to allow you to insert any number you wish. So now I'm going to copy the numbers I have on the table here, and notice that it matches exactly my table. So when X is -6, Y is 15, and so on. And there you have it. So this is how you create a custom table. Instead of having the calculator generate X values for you, you can make up your own X values. So another thing about these calculators and the tables is decimal accuracies and statements. So sometimes a Y value or an X value might have many decimal digits, and you might not see all those digits on the table of values. So notice here the X shows 8.2659, which is accurate. But when I go over to Y, there's 4 decimal places, yet the table only shows 2 of them. Okay, so just keep that in mind about these calculators. Is when the number has many digits in it, you need to hover over that number to see all the digits that belong to that value.